All right, in this video, we're going to do a custom component part. And basically what we're going to do is we're going to do a flat plate embed that is going to be embedded in the wall for deck bearing. Now to get started, I'm going to go ahead and do this as a beam plate. So I'll load up plate properties here, and we're going to make this to be 1/4 inch by 6 inch wide. So I'll just press apply here, and then I'm going to pick the start point, and we're going to make the maximum length on these to be about 10 feet. So I've got my plate in, and I want to make sure that the position is behind, so the plate thickness is going down, which it is. The plate is centered on my picking points, so it looks like we've got really everything that I need here for the main plate itself. Now, I'm a fan of always just doing at least one part here in order to define the custom component, and then I do the rest inside of the custom component editor. So what we'll do here is we're going to go ahead and define a custom component. So we'll say define custom component. We're going to do type part, and we're going to call this deck bearing embed. And remember that the name of custom components need to be unique. So we'll go to the position tab, everything's good here. The advanced tab, this is something that's important. Now, custom parts can be done in a couple different ways. By default, if you don't have this checked, then basically it'll use the picking points that we pick to create the component planes. And that's exactly what I want. If you leave this checked and you modeled in lots of plates or even like a truss, it's basically going to make the component planes at the calculated center of all of those parts that create or make up that custom part. I know this kind of doesn't seem like it makes sense, but I'll just tell you right now for the examples that we're looking for here, let's uncheck this because we don't want to use the center, we want to use the picking points. All right, so we'll say next. In the case of a custom part, basically there is no primary or secondary input. There's only picking positions to put things in. So this plate is going to be created by the component, and so it's going to be a component object. Now, here's the part positions. Now you can either pick one position or two positions. If you only pick one position and then you say finish, then basically what happens is the custom part automatically assumes the second point is a little bit above it, perfectly vertical away from that. So good examples of that might be you only want to pick one point to put in, maybe say like a square embed plate, or to put in a ladder, and you only want to pick the one base point or something like that. The advantage of picking 2 points is you can define the length of the custom part as well as an orientation or rotation. So we're going to pick the start point here, and then we're going to pick the end point, and then we will finish. Now what happens is it creates our custom component, and so if we go to ungrouped items, we should now see the deck bearing embed. Now if we have our selection to components and we double click on that, you'll see here that it's basically got our deck bearing, and we can change the position, the rotation, etc. Now what I'm going to do is I'm just going to go ahead and edit this custom component, and we're going to make it so that way this plate length always follows the 2 picking points. Now the reason I need to do the bindings here for the end of the plate to the picking points is if I actually come in here and try to model in a second embed at 4 feet from my first point and my second point, you'll see that the plate is still to the 10-foot length. So what I want it to do is I want the plate to actually stop here wherever my second picking point is. So to do that, let's go ahead and edit the custom component. And here within the component editor, I'm going to select on the plate, and I want to make sure that here I only have the custom component views open and all the main modeling views are minimized. So this is good here where we'll select this plate. We're going to select the first point or the start point here, and we're going to do right click, and we're going to say bind to plane. Now there are 5 different component plane types, or sorry, 5 different plane types that you can bind to. Boundary planes, for instance, goes to the edges of parts, or the bounding box as you've seen in the previous training videos. But the one thing to watch out for here is that you cannot actually bind a point to a plane on the same part. If I bound this point to like one of these surfaces, basically it would create a cyclical loop because it's the same part. So really you can't glue yourself to yourself here. You basically would be gluing this point to another plane on another part. Now the plane that we're going to work with though is component planes. And the way component planes works is based on the 2 picking points, it automatically finds 3 different planes in the 3 different directions. But there's also a magical fourth plane over here on the end. Here we see, based on the second picking point, that there's another vertical plane that we can actually bind the length of this plate to. Now I'm going to bind this first point to the left plane. Then I'm going to select the second point and I'm going to bind that to the second picking point plane, or this end plane here. Now once that's done, in the variables list, I'm going to see two bindings here, which are the distances, and they're both at 0. Now if I close out and go back to the model, you'll see here that now that second embed that was only 4 foot between the picking points, the plate now matches that. And if I grab this, I actually stretch it across a little bit more, you'll see that it changes. And if I actually make it greater than the 10 feet, then it will also do that as well. All right, so now let's go ahead and get some studs in here. So I've got the studs from this other component, and I'm just going to go ahead and load those properties so that way I can use those. Then what I'm going to do is I'm going to go back into this custom component. So I'm going to right click and say edit component, and we're now back into this view. So just make sure this gets minimized. All right, so there we go, the 4 component views. Now we're going to maximize this, and I'm going to go ahead and model in a stud, and I'm going to go 4 inches down, and I'm going to move this down the thickness of the plate. Okay. Then what I'm going to do is I'm going to go ahead and move this. Let's say that we want to move this 12 inches over, as an example. Okay. Then I'm going to do a copy, let's see, linear here, and we're going to go in the positive X direction. So let's copy this at 4 foot, and we want 2 copies. So let's say the maximum stud spacing is 4 feet. So we've got a 10-foot embed, and I basically have got 3 embeds, 2 spaces at 4 feet, and then so I've got 1 on the ends and 1 in the middle here with a foot left over on the left and right. Okay, so everything looks nice and good there. Now what I might also do is I might come in here and do the weld. So it looks like I've got the all the way around weld from the other embed that I did. So we'll pick the plate, pick the stud, pick the plate, pick the stud, pick the plate, pick the stud. And there we go. We've got basically a full-on embed assembly for what we're looking for here. Okay, now in case the plate thickness might change and I might want to make that parametric, I may actually come in here and grab all of these studs, and I might come in here and say bind to plane and bind this now to the boundary plane. So these studs should be always following the bottom of the plate. And so there we can see those bindings have been added. If we go to the variables list, you'll see 0 and 4. And we should see a total of 2, 4, 6 additional binding distances here for 2 basically on each stud being bound in the vertical direction to the bottom of the plate. Now we don't want that 4-inch to appear on the dialog box, so we're just going to go ahead and hide that. And again, if I wanted to make a parameter to control that stud length, I could come in here and say something like 6, and I could say stud length, and this will appear on the dialog box for the user to change. And I can just go ahead and use this P1 and say equals P1 on each of the 4-inch values, so equals P1. And if you look in the model at the same time, you'll see that the stud lengths are changing. So again, now this is parametrically linked. If I change this, it changes all 3 of the stud lengths here in the model. All right, so how do we actually control the location of the studs? Well, what we can do here is we can grab the first stud, and then what we can go ahead and do is we're going to window around both of those points, and I'm going to say bind to plane. Now, I'm going to go ahead and do my binding here to the component planes again, and horizontally, I want to control the distance from the first picking point or the start point. Okay. Then on this one over here, I actually want to control this one from the other plane. And then this middle one is basically going to always be centered. So I'm just going to go ahead and right click and say bind to plane. Oops, let's make sure we grab the points and not the actual part. There we go. So we'll say bind to plane, and I'm going to use center planes here, which is basically going to be always at the dead center of the plate. So see if I can get actually to it right here. There it is. And that should actually be 0. Okay. So I've got a few of these additional bindings here, and so what I'm going to do is I'm just going to say end offset. So we'll say end offset here, And what we'll do is we'll just say 12 inches, and then I'm going to set each one of these equal to that end offset. So I'm going to say equals P2. And there we go. And so now if you look in the model, if I actually change this at all, if I change this to be, say, 6 inches, you'll see that both the start and the end offset adjust and they change. Let's change this back to 12, and there we go. So now we have a semi-parametric embed here. Now, it is allowing me to adjust. It's not arraying or making automatically calculating all the stud spacing and things like that. But based on the job requirements for what I'm doing here, the maximum length is going to be 10 foot. And so I know that I'm not going to really ever need more than 3 studs in this particular case because I'm just going to make a new embed. Now, if the embed does get shorter a little bit, then I can just kind of tweak this offset distance at the end here, so that way it shrinks up a little bit and works with something smaller than 10 foot. All right, so let's see that in practice. Let's make sure that we've got everything turned off that we don't want to control or don't want on the dialog box. So all these bindings where we had the positive numbers, let's just set that to hide. And now we'll close back, go into the model, and let's take a look at what we've got. So we can see here on the 10-foot embed, everything looks good. 3 studs, 12 inches from the end. All right, so then here we've got a longer embed, right? So it did 3 studs, okay, and it did keep the one at the center, but then here this is greater than the 4 feet. So I would either need to use something that calculates those studs and use the array macro here. You can actually use this array macro and embed that in your custom part, and it will allow you to actually array based on a quantity and a certain distance that you want. I'm not going to show that in this example here, but that's basically how you'd be able to do that. But in its simplest form, basically I now have the ability to just stretch this embed, and basically it figures out where to locate those. So if I just grab this endpoint here, shorten it up, notice that the studs change. And if for some reason I want to actually change the offset on this, just say modify, we can see that that now adjusts and updates. So that's how you can very quickly just make some parametric things applied to your custom part, such as this deck bearing embed here. All right, so let's say that we want to share this component with others or import it into another model. Now we can right click here and say publish. But before I do that, I'm actually going to modify the thumbnail here, so that way we have a better looking preview image so detailers know what type of component this is. Now I'm going to use the Windows snipping tool here, and I'm just going to capture an image, and we want it to be as square as possible so that way it scales nicely here in the preview image. And we're going to go ahead and save, and then I'm going to come up here into the custom component detail model, and I'm going to create a new folder just called bitmaps. Inside of that folder, I'm going to call this file the same name as the component, and I'll just say thumbnail at the end there. Okay, and now we've got that thumbnail. Then if I right click and say thumbnails here, we can then add thumbnail, and inside of the model folder, in that bitmaps folder, we'll choose that, and we're going to uncheck this built-in thumbnail, and we'll select this one, and we'll just say close, and there we go. Now we've got that thumbnail as our preview image there. Now I'm going to go ahead and right click and say publish to export this. It uses the same name as the custom component with a .uel extension at the end, and it's going to export this in the current model folder. So we'll just press save, and now that custom component, including the thumbnail, has now been exported. Now if I want to import that into another model, I just open up that other model, press this button and say import custom component, and then I just go ahead and select that component.uel, press open, and it will then be imported into that model. All right, so that's the basics of a custom part.